Introduction of proximate analysis. Proximate analysis is a fundamental method used in food science to determine the basic nutritional composition of a food sample. It involves the quantitative measurement of key components such as moisture, ash, crude protein, crude fat, crude fiber, and carbohydrate. These parameters give an overview of the nutritional quality and energy content of food, which is essential for product formulation, labeling, and quality control.
So next, objectives. To determine the basic nutritional composition of the food sample through proximate analysis. That's the first objective. Second, to measure the amounts of moisture, ash, and protein, crude fat, crude fiber, and carbohydrates. Third, to evaluate the overall nutritional quality and energy content of the food for product development and quality control.
Okay, now I'm going to explain about the Jodl method used to determine the nitrogen content in a sample. The first step is digestion. We start by weighing about 1 gram of the sample, then we add concentrated sulfuric acid and heat the mixture until the solution becomes clear. This process converts the organic nitrogen in the sample into ammonium sulfide. Next, we move on to naturalization and distillation. Once the digested sample has cooled, we add sodium hydroxide to make the solution alkaline. In this step, ammonia ions are converted into ammonia gas. Then the ammonia gas is distilled and collected in a boric acid solution. After that, we proceed to the titration step. The boric acid solution that contains the absorbed ammonia is titrated with a standard acid, usually HCl. We continue the titration until we see a color change which indicates the endpoint. Finally, we do the calculation. The titration reading is used to calculate the nitrogen content in the sample. So in short, the Jodl method involves digestion, distillation, titration, and the procedure to find out how much nitrogen, and therefore first we start with winning the sample. We weigh about 2 grams of the defected and dried sample and we record it is M0. Then we move on the acid digestion. We boil the sample in 1.25% of acid for about 30 minutes. This step helps to remove soluble material like sugar and starch. After that, we do alkali digestion. The residue is filtered and washed and then boiled again in 1.25% sodium hydroxide for another 30 minutes. This process removes protein and other alkaline soluble substance. Next, we rinse, dry, and weight the residue. We wash it with hot water, dry it in an oven at 100 Celsius, and then weight it again. This weight is recorded as the M1. Finally, we do aging. The dried residue is burnt in a muffle furnace at 550 Celsius for 2 hours. After cooling, we weigh again, and this final weight is M2. Then we use those weights M0, M1, and M2 to calculate the crude fiber content of the sample. So overall, the process includes weighing, acid digestion, alkali digestion, drying, aging, and calculation to determine how much crude fiber is present. Now, I will explain about the solid extraction method, which is used to determine the crude fat content in a sample. First, we start with sample preparation. We grind about 30 grams of the sample to make it fine and even. Then we weigh 1 gram of the dry sample, record it as M0, and wrap it with filter paper or place it inside the timber. Next, we prepare the extraction beaker. We dry the beaker together with boiling stones in an oven at 100 Celsius for 1 hour. Then cool it in desiccator and weight it. This way is recorded as the M1. After that, we move to the extraction step. We place the timber into the solid extractor and start the extraction process using petroleum ether as the solvent. The extraction is usually carried out for several hours, allowing the fat to dissolve into the solvent. Once the extraction is complete, we remove the beaker and evaporate the solvent to get extracted fat. Then we dry the beaker again at 100 Celsius for 1 hour. Cool it in the desiccator and weigh it. This final weight is M2. Finally, we use this weight M0, M1, and M2 to calculate the fat content of the sample. So in summary, the solid method involves grinding, weighing, extraction, drying, and calculation to determine how much fat is present in the sample. Next, I will explain the moisture content determination process. First, we start weighing the sample. We take about 2 to 5 grams of the sample and place it in a clean, dry crucible or dish. We record the initial weight is SM0. Then we move on to drying step. We put the sample in a hot air oven at 105 Celsius for about 3 to 5 hours or until the weight becomes constant. This step removes all the moisture from the sample. After drying, we take the sample out and cool it in the desiccator. Cooling in the desiccator prevents the sample from absorbing moisture from the air. Once cool, we weigh it again and record it as the M1. Finally, we use the 2 weights before and after drying to calculate the moisture content of the sample. So overall, this method includes weighing, drying, cooling, and calculating to find out how much water is present in the sample. Finally, we determine the carbohydrate content using what's called the different method. In this method, we first weigh and analyze the sample for its main component, that is moisture, protein, fat, ash, and fruit fiber. Once we have all those percentages, we use a simple formula to find the carbohydrate content. The formula is carbohydrate equal 100 minus moisture plus protein plus fat plus ash plus fruit fiber. This means we subtract all the other nutrient percentage from 100 to get the percentage of carbohydrate in the sample. So in short, after we know how much of everything is in the food, the remaining portion is considered the carbohydrate content.
The first analysis is protein analysis that uses Jodl method. In this method, sulfuric acid is used, which is 30 ml of sulfuric acid, to find the percentage of nitrogen. Thus, the percentage of nitrogen obtained is 10.749%. Protein are made of amino acids that contain nitrogen. Thus, the percentage of nitrogen is needed to find the exact value of the protein in proximate analysis. Next, fat analysis that uses solid method. In this experiment, 6 replicates have been used, and each of them indicates different percentage of fat obtained. For sample 1 to 3, it contains less than 1% of fat, meanwhile sample 4 to 6 have more than 10% of fat. This indicates that a range of 40.06% of fat obtained in the sample used. However, sample 1 to 3 may have less than 1% due to some errors such as human error or instrumental error. Next, ash analysis that uses muffle oven. In this experiment, 3 replicates has been used, and each of them indicates a different value. The ash content represents the total amount of mineral present in the sample after the organic materials are burned off. Thus, the result shows a consistent ash value among the 3 replicates, which is the mean is 7.5 7.83%. Lastly, we need to find the moisture content by using drying oven for the moisture analysis. In this experiment, 3 different replicates has been used, and each of them indicates a different value of moisture percentage. The mean of moisture percentage obtained is 2.2606, where replicate 1 has the highest moisture content, meanwhile replicate 2 has the lowest moisture percentage. This may happen due to uneven drying or weighing errors. And a low moisture content means that the sample is dry and it can last longer without any spoilage. After obtaining all the data needed, through all the analysis we carried out, we can find the percentage of carbohydrate by using the formula. As we know, the percentage of moisture is 2.2606% and the ash is 7.583%, while the fat is 14.0605% and the protein is 10.7495%. Thus, we can find the percentage of carbohydrate by subtracting 100 with percentage of moisture, percentage of protein, percentage of fat, percentage of ash, and percentage of fiber. However, we don't need to find the percentage of fiber as not really needed in nutrient content labeling. Thus, after some calculation, we can obtain 67.608% of carbohydrate.
My name is Manas. Now I will explain about the principle of fat analysis using the two-step method. Okay, so first, fat is soluble in non-polar organic solvents such as ether or hexane, but it is insoluble in water. This property allows the fat to be separated from other food components. During the extraction process, the organic solvent continuously circulates through the sample and dissolves the fat from it. The solvent carries the fat into the extraction flask. After the extraction is complete, the solvent is evaporated, leaving behind the fat residue. The remaining residue represents the total fat content in the sample. Next is the principle of fiber analysis using the fiber term unit is based on the chemical digestion of the sample to remove all non-fiber component. The sample is unsuccessfully treated with acid and alkali solution at the controlled temperature at about 100 degrees Celsius to simulate the condition of the human digestive process. During this process, protein, fat, and carbohydrate are dissolved and removed, while the indigestible portion, the crude fiber, remain. The remaining residue after digestion and drying represent the crude fiber content of the sample. Next is the principle of moisture analysis using the drying oven method based on the removal of water by heating the food sample. Okay, so the sample is heated in an oven at a specific temperature until a constant weight is obtained. The lost weight after drying represents the amount of moisture present in the sample. This would because water evaporates when heated, while the remaining dry matter stays unchanged.
So, principle of protein. The principle of protein analysis is based on measuring the amount of nitrogen present in food sample. Since proteins are made up mostly of nitrogen-containing amino acids, in the Jordah method, the sample is first digested with concentrate sulfuric acid, which converts the nitrogen in the protein into ammonium sulfate. Then, the solution is made alkaline and distilled to release ammonia gas, which is collected and measured. The amount of nitrogen found is then multiplied by a conversion factor, usually 6.25, to estimate the total protein content in the sample. Next principle, carbohydrate. Carbohydrate analysis is usually done by difference method. This means the carbohydrate content is calculated after measuring all the other components in the food, such as moisture, protein, fat, ash, and fiber. The remaining percentage is considered as carbohydrates. So the carbohydrate, this method works because carbohydrates are one of the main nutrients left after the other components are removed. It gives an estimate of the total carbohydrate content in the food sample. So next, principle of energy content. The energy content of food is the total amount of energy the body can get from it. It is usually calculated from the amounts of protein, fat, and carbohydrate in the sample. Each of these nutrients provide a certain amount of energy when digested. Like the example, protein 4 per gram, carbohydrate 4 per gram, fat 9 per gram. So the total energy is found using that formula. The calculation helps to understand the nutritional value and calorie content of the food sample.
Next, I will explain some challenges and possible errors that can occur during the analysis process. First, sample preparation issues. If the sample is not ground properly or not mixed evenly, it can cause inaccurate result because the composition may not be uniform. Second, incomplete extraction or combustion. For example, fat may not be fully extracted during fat analysis, or organic matter may not completely burn during ash analysis. This can lead to low or incorrect reading. Third, temperature control. Overheating or underheating during drying or etching can affect the accuracy of the result since it may cause loss of nutrient or incomplete drying. And fourth is time-consuming process. Each analysis requires careful preparation, several heating and cooling steps, and constant monitoring, which can make the overall process quite lengthy. Now, I will explain the impact or importance of proximate analysis in food testing. First, it helps determine the nutritional value of a food sample. Proximate analysis provides essential information on the main nutrient, such as moisture, protein, fat, fiber, ash, and carbohydrate. This allows us to understand the overall nutritional composition of the food. Second, it ensures quality control. By knowing the composition of each batch, manufacturers can maintain consistency in product standards, texture, taste, and shelf life. This is very important to make sure the final product meets quality expectations. Third, it helps evaluate the effects of processing. This means proximate analysis can show how methods like drying, cooking, or storage affect the nutrient content of food. These informations help improve and optimize the production process. And lastly is support. It supports product development and labeling. The data from proximate analysis is often used to create nutrition labels and develop healthier or improved food products.
So the conclusion is, in conclusion, proximate analysis is an important method for determining the basic nutritional composition of food. It provides useful information about the amounts of moisture, ash, protein, fat, fiber, and carbohydrate in the sample. The result helped to understand the nutritional quality and energy value of food, which is important for product development, labeling, and maintaining quality standards.